Hello students, good evening to all of you. So here I am going to write the expression or the equations of Hamiltonian equation of motion for this linear harmonic oscillator. So here we firstly write the expression for Hamiltonian, then derive the equations of motion. So linear harmonic oscillator is basically a system that is a conservative system, and we know that for the conservative system basically constant is independent of time. So constant is independent of time there, students. So it is independent, constant is, that is our constant is independent of time. So in that case that H basically represents the total energy. So H is representing the total energy because the system is conservative and it is independent of time. So here we know that Lagrangian for that linear harmonic oscillator, this is a linear harmonic oscillator, so we will simply write Lagrangian as half m x dot square. So x dot is only there because it is a linear. So then the potential energy term we will write Lagrangian is basically L is equal to T minus V. So V is basically half k x square. So that is the expression for Lagrangian for this linear harmonic oscillator. So then students, here firstly we will get the answer for del L upon del x dot. So and that is del L upon del x dot simply is written as like you have to differentiate that. So 2 से 2 cancel हो जाएगा. It is simply written as mx dot. So as we know that del x upon del dot is basically px, or here we can get the answer for that x dot is px upon m. So we'll just simply note that relation for del upon del x. Now we'll write the Hamiltonian, as we know that H is equal to T plus V. So here in terms of this Hamiltonian, the expression for this oscillator is half m x dot square, and like we know that the potential energy term is simply half k x square. So that is the H for that linear harmonic oscillator, students, and we know that x dot is basically px upon m. So it can be written as half m, and in place of x dot we have px square upon m square plus half k x square. So we'll write it like that. So then it can be simplified. So it is a px square upon 2m plus half k x square. So that is basically the Hamiltonian. This Hamiltonian is basically representing the total energy because the system is independent of time. So H is equal to px square upon 2m plus half kx square. Then after we will simply write the expression for P dot. We will derive the equations of motion there. P dot is simply minus del H upon del X. So del H upon del X, students, this is del H upon del X. So it can be simply written as, this is X there. So it is basically minus Kx. So here we can say that P dot is equal to minus Kx, or similarly X dot is basically del H upon del P. So del H upon del P, we will also solve that from this Hamiltonian equation, and this del H upon del P comes out to be, it is like 2 से 2 cancel हो जाएगा. It is simply px upon m. So it is px upon m. That is the value of x dot. So here we have x dot, friends. So x dot is equal to px upon m. So we'll write it as mx dot is equal to px. Then again we differentiate that, we'll get mx double dot, and you know that this is basically px dot. So we can write it as mx double dot, as we know that the value of px dot is simply minus kx. So it can be written as mx double dot is equal to minus kx. So students, we can write this as mx double dot plus kx equal to 0. So that is the answer there. So this is the equation of motion for this linear harmonic oscillator. Thank you.